I'd like to introduce my colleague, Dr. Nicki Colledge. You've heard about her, geriatrician, and she's going to be talking about Parkinson's disease, and I'm sure you'll find this very interesting. Nicki.
Well, good morning. I'm absolutely overwhelmed to see so many people in the room, but also delighted to have the chance to meet so many of you, and I hope there's one or two of you that read Davidson's out there that can tell us afterwards what you think. So over the next half an hour, I'm going to talk about Parkinson's disease. So Parkinson's disease is a chronic degenerative neurological disorder, and was first described by James Parkinson, who was a British surgeon, in fact, in 1817. He called the condition the shaking palsy, or paralysis agitans, and it was only later that it came to be known as Parkinson's disease. So what I'm going to cover over the next little while is something about the pathophysiology and etiology of Parkinson's disease, its epidemiology. I don't think I'm talking loud enough, excuse me. Okay, so as I say, what I'm going to talk about over the next few while is the pathophysiology and etiology of Parkinson's disease, its epidemiology, something about its clinical presentation and diagnosis, and finally how it's managed and the drugs that can be used for it. So there are two pathological hallmarks of Parkinson's disease. The first is loss of dopamine-producing neurons in the substantia nigra. The degenerating neurons contain a lot of melanin, which is removed when the neurons die by the microglia, so you can see the pallor that results in the substantia nigra in Parkinson's disease. The second pathological hallmark is the Lewy body, and these are eosinophilic intracytoplasmic inclusions which contain degradation products, and they're found widespread throughout the nervous system, in the cortex, the thalamus, brainstem, spinal cord, the sympathetic ganglia, and even the myenteric plexus in the gut. So the results of losing these dopamine-producing cells in substantia nigra are quite profound in terms of motor function, and they play a key role in controlling that. But 80% of the dopamine has to be lost before the signs and symptoms of Parkinson's will emerge. And just how the pathophysiology arises, you need to understand a little bit more about the neuroanatomy of the basal ganglia in the brain. And this slide shows the relationship between the substantia nigra and the other structures within the basal ganglia, that is the subthalamic nucleus, the putamen, caudate nucleus, thalamus, and globus pallidus. And together, all these nuclei and structures interact with a very complex series of parallel networks to produce a balanced output from the thalamus, which acts on the supplementary motor cortex. And this is illustrated in this rather ghastly slide, which looks like a road map of some sort. Don't worry too much about where all the lines go. The important thing to note is that the output from the substantia nigra, which is right down at the bottom of the slide, is on the putamen. But the dopamine has two effects. It excites the dopamine 1 receptors in the putamen, but inhibits those of the D2 receptors. And through that mechanism, as I say, helps to produce this balanced output from the thalamus on the supplementary cortex. If you lose dopamine, the ultimate result is excessive inhibition of the thalamus and much reduced stimulation of the supplementary motor cortex, thereby resulting in the reduced movement and slowness that you see in Parkinson's disease. So what causes this loss of neurons from the substantia nigra? Well, the answer is we don't really know. At present, the hypothesis is that it's due to damage by an environmental toxin in those who are genetically susceptible to such damage. And the evidence that we have for this comes from two separate strands of research. The evidence for a genetic predisposition is, first of all, that a family history of Parkinson's disease increases your risk of it by 50%. The other evidence comes from studies of very rare family lines of Parkinson's disease, in whom more than 10 autosomal dominant and recessive genes have been identified. And in some cases, the products of these genes have also been identified. For instance, the Part 1 gene product is alpha-synuclein, Part 2 product is Parkin, and the Part 5 product is ubiquitin. Now, quite what these products do is as yet unknown. It's thought that they may have some role in neuronal degeneration. So the other strand of research which has proved helpful is looking at environmental toxins. Herbicides and pesticides are known to increase the risk of Parkinson's disease, and people that consume well water, again, seem a greater risk. A greater risk if you live in a rural as opposed to an urban community. But perhaps the best evidence comes from MPTP. Now, MPTP is a byproduct of pethidine synthesis, and back in the 80s, a group of drug users in the States tried injecting this IV, and all subsequently developed Parkinson's disease. So very good evidence that a toxin can induce the disease. Smoking, strangely, seems protective. If you smoke, you're less likely to get Parkinson's disease. The amusement over this, and it's thought perhaps not to be a direct effect, but there's a so-called, it's quite interesting, Parkinson's personality trait. And the people with Parkinson's disease, not always, but many, seem very introverted, a little cautious. And it's thought perhaps because of that, they avoid risky behaviours like smoking, so that you get an artificial finding like this. So please don't smoke. So what about epidemiology? Well, the incidence of Parkinson's disease varies between about 8 and 18 per 100,000 population per annum. There's a slight male preponderance, and it tends to occur in older age, between, say, 50 and 70, and it's a worldwide condition. Perhaps slightly different prevalence in different races, but it occurs worldwide. These figures under prevalence are UK-based, but 1 to 1.5% of our population suffer from Parkinson's disease, and that increases with age, and 2% of people aged over 80 are affected. 120,000 people sounds like nothing in a country like India, but for a small country like the UK, that's quite a lot of people. Estimated 6.3 million affected worldwide. So what about the clinical presentation? Well, I'm sure many of you, particularly those in your senior clinical years, will have it drummed into you that the key features of Parkinsonism are bradykinesia, rigidity, tremor, and also impaired postural reflexes. Now that's all fine and well, but have you ever had a patient come to you and say, "Doctor, I've got this terrible rigidity, and I've all got